Well, good morning. I figured they buried me at 9 a.m. because they didn't want me to talk too long, so they made the right choice. I'm not particularly a morning person, and my workout didn't happen this morning. So we'll struggle through this if you can just keep up with me as we go here and keep me honest as we talk through things. So anyone who's seen the last 2 years of presentations that we've made here and IO's participation at Uptime Institute and the symposium here have been around the transformation of the data center from what, in our view, has been not our view, but what has been a facilities-based approach to delivering data center capacity to a standards-based modular approach to delivering data center to now what we'll talk about today is a software-driven approach to delivering data center and managing data center. So it should be an interesting conversation. I'm hopeful to keep it a little bit short so we have plenty of time for questions. I like the interactive nature of the discussion. And so we'll go ahead and jump in. The title EOL is a product term, right? End of life. That essentially what I want to talk about today is not, in fact, if I've been effective, talk about data centers, but talk about everything that's in data centers and everything that are outside data centers, because that's what actually matters. Despite what we think, IT, capital I, capital T, does not care about data centers. And nor do they want to. They want to care about applications and users. And they want infrastructure to disappear. And our job, if we do it right, is to make that infrastructure disappear. So end of life, term used to indicate that a product has ceased to be useful, right? That we've ended the life of a given product. And we've all had this happen to us in the IT world. One day Cisco sends an email and says, hey, that platform you invested all this capital in, or you made all this investment, time, energy, and effort, we decided not to support it anymore because we don't believe it's the future of infrastructure or technology. Similarly, our view is that Data Center 1.0, which we've talked about now for some 24 months in 3 different presentations, including this one, is at the end of its paradigm and at the end of its useful life. Doesn't mean that it's not going to persist and we now have these assets on our balance sheets and we don't have to manage these assets and utilize them in the future. But at the end of this, at today, 24 months from 2 years ago, when I said that I felt that the last facilities-based or construction-based data center would be started or completed, I believe we're there. And I would like to take just a brief poll of hands. So how many people here have Data Center 1.0 style data centers? Legacy, facilities-based, bespoke data centers. I do, right? Like everyone does. How many of you plan on building a non-modularly architected data center in the future? So I see 2 hands. So the good news here is that at the end of the day, we've made a decision as an industry and as I guess, suppliers to our customers, IT consumers, to take a new approach to how data centers are delivered. Right? So we're going to go ahead and declare Data Center 1.0 dead. Right? We're going to put it in the ground, and we're going to let it rest in peace. So we can move on. Because we have to move on to standardized infrastructure, standardized hardware, standard-based delivery, manufactured capacity, right? All of these things we've talked about. And we shouldn't feel bad, because there's a lot of technologies that should have been 8-tracked that still exist today. These are 10 things that we identified kind of going through our analysis and just kind of back of the envelope Googling of extinct technologies that still persist, right? So we have legacy constraints. We have legacy data center. We have Data Center 1.0, but the next step has begun and we have to move into it. And the next step even beyond that is maturing as we speak today. Why? Why do we have to leave 1.0 behind? We love it. It's comfortable. It's easy. We know how to do it. We've been doing it for 30 years, right? You write down a spec. You pick 5 or 6 parameters. You hire engineers and consultants and architects. They design it. They pull plans out of a can. You go hire the same guys who built the last one. You build it, you deliver it, and you're done, right? The problem is nothing else has stayed the same for 30 years. The things in the data center have changed. The things using the data centers have changed, and the acceleration of that change is making it impossible to keep up. If we're going to continue to use this traditional approach, we're not going to be able to keep up with these megatrends. So I want to walk through some of these megatrends and the way we view the world. So how we view the world is essentially there's 4 mega trends occurring in the 4 primary layers of the IT stack. We believe there's 4 layers of the IT stack. We believe that at the very foundation layer, you have what we call data center infrastructure. The next layer, you have enterprise infrastructure, which is your CPU, storage, network devices. You know, we all have been in data centers. You know there's really only 3 things that sit inside data centers. There's CPU devices, processors, there's storage devices, and there's network devices. The next layer above that, you have the application layer, or we call application infrastructure. That's the layer that's soft, right? That's all the things that actually IT people start to care about. And senior decision makers in IT really care about. And users, all of us, and all the things that connect to those applications, we care about. We don't care though about the physical infrastructure that delivers those services we consume. We care about getting those services we want and getting them when we want them, how we want them. And then at the very top of the stack, which is usually left off, is the user. And in fact, my assertion today will be that this is what's driving ultimately this change in the most pervasive way we've seen in a very long time. Right, that essentially we're seeing this transition of consumers of IT services, right? The data center exists for one reason, to keep applications connected to users. That's it. Users, however, there's inside of this megatrend, there's 2 things that are fundamentally shifting. One, we're seeing this megatrend from human users to machine users. Up until today, really 2012, people have been the most significant and quote unquote most important consumer of resources in the application sphere. It's been us. And think about humans. We're not patient, right? I think the average expectancy of presence on a website page is about 7 seconds if it doesn't load. We wait, we go, right? We want it now, we want it fast, we want it the way that we asked for it to be delivered, we want it on the device that we want to consume it, right? So it's very unique. However, what's happening is in 2012, the number of machine consumers of resources surpassed humans, and now we're in an unbounded system, right? People are actually limited by the number of people on planet Earth, the number that have access to high-speed internet, the number that have access to devices capable of accessing that high-speed internet, and then the number of hours in the day that we're awake. Now, we're doing a very good job utilizing these devices to be connected every hour we're awake. You know, my battery ran dead last night, and I went in Android, you have the ability to see what's consuming all the energy, and the screen was on 11 hours yesterday, right? I was probably up 18. So, you know, majority of the day was connected to this device. The second, inside of this trend though, from humans to machine, there's 2 fundamental shifts that are occurring inside of the consumption and user base. There's massive consumerization of users. We have the best user experience we have at home now. When I was a kid, I don't know about you, I used to beg my dad to let me go to the office with him. You know why? Because at the office was all the cool stuff, right? There were printers and color printers and all of these other tools that I wanted to go there and play with. There were computers there. There weren't computers in our house when I was a child. It was at work was where the technology list existed. It's not the case today. The best technology we consume and the best technology we interact with is in fact in our palm of our hands, and it's typically free to us because it's being subsidized through some commercial mechanism, advertising, marketing dollars, or some type of subsidy providing access to it, and it's incredible because you have companies that surround this area, Google's and Amazon, well, Amazon's in Seattle, Microsoft, which is actually in Seattle as well, so I guess Silicon Valley doesn't have as many of these companies as they claim. I always joke because everybody's like, we're so innovative here. And I'm like, well, there's a lot of companies outside of Silicon Valley that does. But the point of it is that these people are training us how to consume resources. And how they're training us to do it is always on, best of breed, and at no cost. And so what do? When we connect to the internet, we connect commercially, when we go to the office, we want the same exact interaction. And when we switch from Facebook to our bank, we want our bank to deal with us the same way Facebook does. We want to be able to use our phone to deposit checks. We want to be able to do it from anywhere in the world. We want it to be pervasive. These things aren't how IT have been built. So it's putting enormous pressure into these organizations to accelerate and move towards that construct. The second component of the transformation at the user layer that's important to data centers is mobility. The PC is going away. They're not going to exist 5 years from now. Spent time with my nephews. I don't know if you have a chance to spend time with 7, 8, 9-year-old kids. They don't know what a mouse is. They look at it like it's some kind of awkward device that no one would ever want to use, right? right? They touch everything, they swipe, they have all the gestures down. I mean, they're pros at running my phone and running the iPad and running all these other things. And I'm like struggling, I'm trying to find a mouse, right? So I can actually click on things. So the point of it is the PC's going away. So consumerization of IT, the transition from people to machines being the primary consumer, and the fact that now mobility is driving how we access everything, changes everything below it. Data center professionals in general, and I include myself in this, like to live where we live. We like to spend time down here in the data center infrastructure and just assume, oh, the rest of the guys are going to tell me how to do it, and then I'm going to do it, and I'm going to be okay. It's no longer the way it can work. The data center has to be integrated all the way up to the user layer, and it has to take command and control from the user and dynamically provision how it's going to react, just like the rest of the stack does. It has to get there. This isn't a question mark in my mind. This is a necessity of these changes. The other thing about machine users that's interesting is if people have these irrational demands on IT infrastructure, always on, always available, right now, right? Machines don't. So a friend of mine just bought a new Audi, and he paid the $14 a month or whatever to get an IP address assigned to it. And now it's a node on the network. I was looking at the cover. I was actually going to carry it up with me. Cover the Wall Street Journal yesterday. There was a picture of an X-47 drone sitting on top of an aircraft carrier. And yesterday did a demo flight out in Virginia. First time a drone's launched off an aircraft carrier, at least publicly disclosed. They're going to deploy an entire squadron this year. No people, which means data centers, right? Data centers are running these things. Machines are different. They can queue. They can take instructions. They'll wait. They'll parallel process. They'll run when you don't need to run. Imagine a world where the data center can tell you when you can access the data center to be most efficient. That's what the machine world is going to drive. Next layer of the stack. And all these things below this are happening because of what, in my view, what's happening at the top. Application infrastructure, the macro trend here is going from what we've known in the past as discrete application architecture, one server, one device, one OS, one application, one database, one set of I/O, to a platform construct, right? This cloud architecture. The concept of having an ether of application construct that's software-defined everything. You can access resources when you need to. You can provision them when you need to. 5-click provisioning is something we talk about now. Our good friends at Service Mesh have accomplished this in their technology platform. You have the ability to provision resources very, very rapidly. This is what the cloud's about. If you want to understand, in my view, what AWS is about, what the cloud is about, is making infrastructure disappear for users, right, for folks that deliver data center, because as my original assertion, IT professionals don't care about data centers or infrastructure. They care about applications and users. AWS provides a construct for them to care about those things and those things exclusively. This is what this application architecture is moving towards. It's going to completely commoditize everything below it. And it's going to create an interface for everything below to talk to it in a smart and intelligent way. And if we build dumb data centers, they're going to be 8-tracked by this layer, and people are simply going to move their workloads to places where they have smart data centers. And when I say data centers, I'm now talking in the capital D, capital C, the data center, right? Next layer of the stack, and all these things are accelerating. Now, even it surprised me where we're at today. The number of our customers coming to us pushing this is all of them. They want fully converged infrastructure, which is a segue to the next. They want converged application construct. They want it 1 click to buy, 5 clicks to operate, and that's what they want to, and they want to buy it per drink, right? Next layer of the stack is the enterprise infrastructure stack. This is playing out right before our eyes. It's going from what we have seen in the past of branded infrastructure, big brand names, cardboard boxes, lots of cardboard boxes, right? Onesie, twosies, we buy them, we put them together, we put them in racks, we cable them, we spend more money than we spend on the server to put it in, to support it, and then to maintain it over its lifespan, to absolutely, completely commoditize infrastructure over the next 3 to 5 years. Meaning white label, we don't know what it is, we don't care how it works, and if you look at what's happening above, it's making this happen. The brands are going to disappear. The tumult we see with HP, the tumult we see with Dell, the tumult we see across the industry. When you sit in a CIO's office and you hear these companies described as a tax, people don't like taxes, and we're learning this, right? It's the great state of California, right? We don't like taxes. Next layer is the data center infrastructure layer, and it's very simple what's happening here. The macro trend is accelerating. The macro trend went from facilities-based approach to modular facility-based approach to, which is just the same plans over and over again, to a manufactured approach, which we've espoused and been driving, of a manufactured appliance, a standards-based, to what we now believe where the next step is fully converged. I don't believe that you'll see a single piece of data center delivered without the application and without the enterprise infrastructure embedded in it within 5 years. It will come as a single unit, and it'll operate as a single unit, and they'll interface to it through software. So why? Why are these things happening? What is the outcome? So 2x, right? So all of these things down here, cloud, cybersecurity, energy waste inefficiency, and I've just labeled China here, as China's gonna have 800 million users in and of itself. Imagine all of them now have cars. Imagine all of them now have smart homes. Imagine all of them now have, pick a number. How many IP addresses assigned to each one? 5, 6, 20, 100? Massive explosion of connected users and the outcome of these connected users. This is by 2015, by the way. This is 2.5 years from now. By 2020, there'll be 50 billion machine users online. 2003, and the black dot that turns the gray dot's us. We're getting eviscerated by the machines. And every one of these machines are creating more data. They're creating more things to analyze. They're driving more decision, more analytics. Big data is called big users. The other thing about machine users are, they work 24 hours a day. Nest. Nest is one of the biggest ideas I've seen in a decade. This little thermostat that sits in your house, it's Wi-Fi enabled and has sensors on it, that intelligently figures out what's going on. It predictively analyzes how to use your energy in your house. It's going to connect to everything else in your home and then tell it how to run. Why worry about the distribution grid if you can control the load? Why worry about how the data center is built if you can control the application that consumes the data center? And then, what is it by 2050? 1,000x, 1,000,000x, 10 millionx? I had been in the past, last 2 years, I talked about the data creation, IDC's prediction. I think this year they ceased to make a prediction because they've been so far off for the last 2 years in kind of 12-month fidelity that they just no longer make a prediction. We don't know how big this is going to get. All we know is it's getting big. Yesterday I spent some time at Mark Andreessen's office in Palo Alto. Software eats everything, right, is Mark's pitch. He's right. And software is going to eat the data center too. IT transformation. So real quick, I want to run through how we view transformation, how I view transformation in IT, and why we think about the things inside the data center and outside the data center, and why we think that the box, the module, the building is irrelevant to the discussion going forward. First thing in IT transformation is, in our view, there's 4 steps. My view, there's 4 steps. First thing is you have pain, and I'm going to use a tortured analogy of how we, of medical treatment. Just stick with it. It might be good, it might not. First thing is we feel pain, and we don't. At least the data center industry hasn't, because we just let the IT guys tell us what they need, and then we deliver it to it in the past. That's not the way it works anymore, but that's the way it's worked in the past. Hey, I need 3 megawatts, I need it this resiliency, I need it in this location, and then they run off and build it, and then they hand it to them. Great, good job. It's not the way it's going to work, because the IT guys feel pain, and they feel pain across the stack, and each time, my view is every time they feel pain, you go through these steps, and these steps end up in a transformation, and technology being invented to solve the transformation. So the pain for a company is when value is exceeded by cost, where the value derived for it by some component of technology, one day they look up and it costs more than the value it provides. And when I say cost, I mean capital C, right? People, time, effort, energy, dollars, right? Dollars is one component of it, it's measured in many, many vectors, right? when something goes from being a strategic asset to the company to a tax is this transition. When CIOs are like, we have to have that technology because it differentiates and changes our industry, to going, we got to get rid of it because it's taxing my company, that's what I'm talking about here. What happens in the next step is, because our customers, consumers of IT, aren't innovators. They're not paid to be innovators. They're paid to run applications and deliver services to users. So they attempt to solve it the way they can. And in my view, it always shows up in some form of outsourcing first, right? You treat the pain. You don't fix it, you treat it, right? You just hand people aspirin, then you go to Percocet, and then you go to some, morphine, right? You just keep giving them stronger and stronger sedatives so that they don't feel the pain anymore. But at the end of the day, it's continuing to mature because all of these growth vectors or attributes that we've seen are pushing this along, right? So we outsource. We just make it, your mess for less, right? Just give it to somebody else. And what happens is that value cost threshold inverts for a short period of time. Because for some reason, the person you're outsourcing to is willing to do it for less dollars. They have a more efficient platform. They have a capital access strategy that allows them to invert things. Somehow they're dealing with it. But again, it's not a sustainable solution. If we look through the IT cycle, IT stack, over the last 3 decades, we've seen outsourcing movements. In software, we've seen it in storage, we've seen all of these other layers where there's been pressure, and in every instance, the outsourcing doesn't last. How many times has American Express gone in and out, right? Outsourced, insourced, outsourced, insourced, right? The point of it is that it isn't sustainable. The third step is someone actually takes a step back, or a group of people, or an organization, or an institute. Somebody takes a step back and actually listens to the customers talk about their pain and attempts to diagnose what the actual problem is, right? And what is the real problem? What is actually causing the pain? And then, is it a broken leg? Is it cancer? Is it this? What is the actual problem? And then the final step is where an innovative set of companies or innovators figure out a way to completely invert the value cost curve for a period of time. Storage is one example I use. The value of having a storage device in every single server at one point in time made perfect sense. That's what we did. And then someone came along and said, hey, let's take all those storage devices that are utilized at 3% and put them in an array, and let's let everything connect to that array, and then let's use software to automate that so you can do cool things like thin provisioning and quality service and tiered storage. Huge strategic asset to the company, right? Inverted the value costs, everyone bought it, implemented it. Now that's becoming cost prohibitive, it's becoming a tax to organizations, and now we see software-defined storage, right? We just keep seeing these cycles. My assertion is we're seeing the first cycle in the data center space. The first grand cycles just happened. So, pain versus cost. It doesn't matter if the curve's declining at an accelerating at an accelerating rate, decelerating at a decelerating rate. However the curves get to this nexus is where is the point at which a transformation starts. The time from when that crosses to the time that you're able to deal with it, and then the change occurs, could be variable. It could be years, could be months, could be decades. So, how do we medicate right now? I'm going to walk through this from a data center perspective, in our view. So we do 4 things right now when we deal with data centers, and I try to be, my marketing team's really fancied up my presentations this year. As you guys know, just like the words before, now I got pictures, so I have to kind of decipher what they're talking about. The first is we start monkeying with our balance sheet, right? We try to fix it financially. We don't fix the actual problem, right? It's real estate. Let's give it a 37.5-year useful life. Boy, that fixes a lot of problems when you divide something by 37. It's small, right? It's like a 10-year car loan, right? Imagine if you could finance your car in 30-year terms, right? You have a $60 a month payment, you could have a 911 Turbo, right? Doesn't mean that it's actually going to be useful for 30 years or that you've done any of these other things. The other thing is you can outsource, right? That's really monkeying with the balance sheet. It's making what should be a capital asset into an operating asset. It's somehow dealing with this in a financially engineered way. Again, it's only going to work for a limited period of time. It's not going to be a long-term solution, right? Second is to, as I described here, get your cloud by the square foot. right? Doesn't make a whole hell of a lot of sense. Why would you ask someone to sell you something that has no actual ability to understand or deal with what you are using it for to buy something from, right? This isn't real estate. It just isn't. But we found a mechanism where we could buy something cheaply by calling it real estate, right? Water flows down the mountain. Third is you call it what it isn't, right? That's a dog. No, it's not. It's an elephant. No, it's a dog. You just keep insisting it's what it's not, and eventually people around you go, okay, yeah, that's right, this is a big dog, right? And we've seen all these things happen inside of our customers, in our own organizations, when I spend time in large cap IT, and this is not just limited to enterprises anymore. This is web scale, this is enterprise, this is service provider, this is government, right? And the dog thing is essentially, call it cloud, and it's just outsourcing. Call it, pick whatever you're going to call it, and let's try to just blossom over it, right? The third is your mess for less. We've talked about outsourcing. Again, all of these have an outsourcing theme to them or underlying component, but again, this is how you medicate. You just keep tossing aspirin at it and hope eventually you work your way around it, but it's not going to happen, and it hasn't happened. Next is from a diagnosis perspective. So again, looking at the things inside the data center and looking at the things outside. So applications and users. This is how we're making our decisions today on roadmap and how we're talking to our customers. These are the things that you look at when you talk about an application provision. Location. Where are my users at? Where does my application need to be? Capacity. How big a box do I put it on? How much network do I give it? How much storage do I get? How do I manage capacity? How do I manage density? How dense of a compute environment do I need to actually facilitate this application? Also in location is, does it need to be on my prem? Can it be on someone else's prem? Can it be in the cloud? Which is just someone else's data center, right? So there's just three types of data centers. There's ones you own, there's one someone else owns that they give it to you on a service basis, or there's one someone else owns that you never even see and they just give you an API, right? Resiliency. How important is this application? Availability. How often does it need to be up? Because resiliency and availability are two different things. Efficiency. How efficient do we want to? Do we care? Is it the most important application in our company? So we don't care how efficient it is, we just need it to work? Or is it something that's consuming enormous amounts of data and space and capacity, and we need to run it as efficiently as possible? And then finally, security. Every application that gets delivered into an IT stack, you make these 7 decisions. And I think resiliency and availability are tied, but they're different, but they're tied. All right, let's not think about applications now. Let's think about data centers. These are all the things you make a decision about data center around. Where are you going to put it? Right, there's a consultant for every one of these today. Right? Literally, hundreds. You can find them, and they'll charge you $100,000 to tell you where you should put your data center. They'll charge you $100,000 to tell you how big it should be. They'll charge you minimum $100,000. Right? It's kind of like when I remodeled my house, everything was $1,000 increments, no matter how you cut it. Right? So the point of it is, these are data center attributes. The problem is, if you look at applications and you look at users with regard to these attributes, every one of these attributes from a user perspective and application perspective change. They change in microseconds. How many users are accessing from Europe right now? How many are accessing from US right now? How many are accessing from Australia? What are they accessing? What's important to them? Watch Twitter. I've become fascinated with Twitter because it self-selects what's important. The user community tells you what's important to them, right? You think about the way media used to work. Media told you what was important. Read this article, it's on the front page, it's really important. Twitter tells you what's important because people tell them, it tells itself. It's a self-regulating system. So again, these attributes in a data center are today, in the legacy approach, are statically provisioned. But in the application world and the user world, they're all dynamic, instantaneously dynamic. So what happens because of this static nature, I heard someone yesterday describe that things don't change and that's why you don't need to control them. That's not true at all. You just don't know what's changing because everything in a data center is changing every second. So you have this statically provisioned set of attributes with a dynamic system in it, and what you end up with is a boat anchor. It's dragging your enterprise from where it should go to where it has to be because of your legacy constraints. You have to unhook this static connection. You have to tie the application and users to the data center. So the cure, the way we view it, is intelligent control. That essentially this is the virtuous circle, the life cycle of a data center. And the way it should be thought about, because it's the life cycle for applications, it's the life cycle for users, right? You assess, you deploy, you provision, you run, you re-provision, you run, you upgrade, you provision, you run. And these things can happen in the day. And the data center needs to be able to do the same thing. And below, we have these little people attempting to show one shirt fits all idea with data centers. Today, because we statically provision all these attributes, and we just monitor those static provisions. Does anyone wonder why DCM's not taking off? I don't. It doesn't do anything. It doesn't tell us anything interesting. I can stand in front of a UPS and go 400 kW, 400 kW, 400 kW, 401 kW, 420 kW, 423 kW, 400 kW. That's what it does in what I've seen. What you need is something that controls this circle and coordinates the activity in the data center with what's happening in the application stack. And you need an infrastructure layer, standardized, that can make these changes based on software calls. Run this module this way, run this rack this way, put this rack important in front of this rack as far as quality of service. Thinly provision the expensive resources. So thinly provisioned storage means massively oversubscribed. So you create all these servers in your organization, you give them all like 20 gigabytes or a petabyte of storage or whatever the number is, and in the actual storage array, there's 1% of that. And when you get the 80% of utilization of that 1%, then you add more. We have to start doing this at data center layer. And as these things progress, at the top two layers I talked about, the application layer and user layer, this is not going to be a nice to have, this is going to be a have to have. Because if we're going to connect every single person, every single machine in the world with some type of high-speed connectivity to data centers, they can't keep running the way they are today. They have to be able to match the user request with how they provision and deliver resources. Most of the data center, in my view, should be on street power. And you should solve availability in the application stack. I don't think we need to provision a single new generator in the world today for data centers. If we utilize the ones that we have today at their full capacity, we could cover every piece of critical application infrastructure that requires that type of resiliency and availability today. The goal is, the IO's goal is to commoditize the hardware component to the point where it's basically the cost of the goods that's in it and automate it with software. And remove all of the resiliency elements from 90% of the applications. So if you get to this panacea, which we're doing for customers today, and we're going to show, I think some of you hopefully have had a chance to get to the booth and see Ivy, which is our immersive virtual environment that we developed for our data center operating system. You get to a point for, at least for the next event horizon, value always exceeds cost in this place. You're able to make sure the cost of your deployed resources, the logistics of your IT inventory match up with the applications and the users consuming them. So commodity data gets commodity data center. Proprietary data gets proprietary high resiliency data center. Transient data gets put to the lowest cost cloud assets in the world. Maybe it goes to Mega, right? Maybe the guy in New Zealand was right. Right? He charges what? I think he's 10% of the cost of Google's storage platform. Now, it's because everything he's storing is the same, and they dedupe it down to one file. But the point of it is at the end of the day, you're going to need a panoply of options when you're assessing and managing your IT inventory. So my proclamation today, and it's been put out there, I believe that today forward, every important innovation in data centers will be made by software. Software is eating and has eaten the data center. And if you don't have a data center operating system, something that's able to combine those elements of monitoring, telemetry, instrumentation, combine them with an ability to optimize and thinly provision and thin slice capacity, and connect it to the application and user stack through an API, you're just going to get 8-tracked by someone who will. And we're seeing this with AWS. This is what AWS does. You should be paying very close attention to it. That's what AWS and Google Compute and Azure and these tools present to the end customer. Our largest global customer is running, this summer, is going to be moving about 15% of their infrastructure to AWS. Using our tool, so they can see the inventory and manage which ones goes where. This is happening today. So real quick, and these are the metrics I believe that we're going to measure success or failure going forward from a data center perspective. How many people are connected? If you want a standards-based approach, you have to have customers using it, and you have to have the largest customers in the world, right? You have to have users connected to this OS and using it. Machines, people, right? You have to have an ecosystem. You have to have data, and lots of data, and smartly managed data, and curated data. I'm looking at the gentleman that runs our performance engineering team here in San Francisco. He's the guy who controls the data in his team. What do we do with it? How do we think about it? How do we simulate it? Next year, we'll be unveiling a full-blown simulation environment for our technology. First-person shooter style. So if you want to simulate your IT infrastructure globally, we can build a full simulation model and run it through cycles and cycles and cycles and decades and years of operations to tell you how it works and how it doesn't work. Right? How sustainable is your environment? Right? We don't care about CO2 in the United States because energy's free here. I know it's not a popular thing to say, but it is. Singapore is 30 cents a kilowatt hour. Phoenix is 5 cents a kilowatt hour. It's free. It's not free everywhere else in the world. Gas is $11 a gallon in the UK, right? How many people are trained on your platform, right? 500 plus trained professionals, right? And growing every day, right? And how pervasive is it? 4 continents today, right? You have to be thinking about what platform you're going to pick and where are you going to position yourself to be successful with your application users and your application developers and your users when they say, I need this type of flexibility because AWS gives it to me, and if you don't give it to me in my data center, I'm moving. So we're going to bring up Dana, a gentleman on our team, and I think everyone's seen it. I just want to put it up there because I think our immersive environment, there's some subtleties to this I just want to point out that tie together this entire conversation, what a data center operating system is. And the reason for the visual nature is dimensionality, guys. People think it's just like we want to build something that's, looks good, it's eye candy. It looks good, but it looks good because it serves a purpose. In a picture, how much data can there be? A lot. A lot. We all know this by our grandparents and parents sending pictures of the nephews and kids around, right? Right? You take a 36 megapixel file, there's a lot of data there. That's because in every pixel there's information. And so in an immersive picture like this, you can show a lot of data in one view. You can use colors, you can use speeds of things moving, you can see all of these attributes, the things spinning in the sky. So you're looking at this immersive environment, you're looking at a virtual representation of actual data. So another thing this isn't a video. This dynamically renders from things sitting in our data centers for our customers. So a customer can connect to this and see what their data center looks like and what it's doing. More importantly, who cares what it looks like, what it's doing, right? In the sky above are the cloud service providers this particular module is connecting to right now. Google, Compute, Azure, AWS. Those are the resources it's consuming right now that aren't in this application module. You climb inside the module, and you can actually see things. We can augment reality for you in a virtual way. You can see temperatures associated with given devices. You can see what applications show SAP running. So you can see SAP ECC6 is what's running in that rack, right? And it's real. That's what's really going on in that rack right now. The buttons you see on the servers are the actual buttons, and we're moving towards a construct where you can push those buttons virtually, and it actually modifies it on the device, right? Because it's all programmatic. This is what a data center operating system gives you the ability to do. And then in a simulated environment, you can take the same data and you can simulate its behavior and then look at it again. The other thing you can do with this, which I don't think we've been talking about, it's in the next rev, is you can in fact create synthetic virtual environments. So let's say you're the guy who runs caching servers across the entire organization. We can create a synthetic view that's this virtual environment that takes your servers out of 100 data centers globally and puts it into one virtual module so you can see it. And then you can control it physically, but through a virtual interface. And this ties all of the telemetry and instrumentation that we pull from a standard set of tooling inside the modules and all of the things external. The cloud, SaaS, how are you accessing these things, your network latency, and then in this visual environment, you can present this in a multi-dimensional way, right? That's the point of this, is to show what can be done. Because if we keep looking in the rearview mirror, data centers are going to get replaced by people who do this. And so the point of bringing this up, and we have a big display out in the hall, is to show this absolute convergence of software with the data center. I always try to find something relevant to talk about as I drive over to each of these. And what I thought was interesting, I was sitting in my rent-a-car. There was a navigation, well, first of all, I was sitting in a rent-a-car, I'm sitting at a stoplight, I'm looking at all of these cars around me, right? So cars functionally haven't changed from a physical hardware perspective in decades, other than the one Tesla sitting over to the side, right? That's a paradigm shift, different, right? All the rest of them had internal combustion engines, all the rest of them had four-stroke motors, all the rest of them had brakes, all the rest of them had four wheels. The hardware is the hardware. Then I looked down at my dash, and I realized there's a navigation system inside the car. There's a navigation system the rent-a-car company installed on top of it, and guess what I'm using? Neither of them. I've got my phone on the dash using Google Maps. Because you know what Google Maps knows? Just like this, it knows things about me. It knows the restaurants I like to go to in San Jose, and it knows the restaurants I like to go to in Palo Alto. It knows that I go to Starbucks every morning. It knows I don't like to wait in traffic, knows I don't like toll roads. It has all of my personal attributes tied to it. And this is what the data center and the application construct needs, is relevance to its users and relevance to the people that control and maintain it and relevance to its purpose. And that's what a data center operating system does. And DCIM is just one little tiny component of this stack. Sure, I can look at the wall and it tells me what the temperature and the relative humidity is. Now that doesn't actually exist on the wall, right? That's a composite for the module. And in fact, we could put up there the planar temperature for all the servers in the room. We could actually create a synthetic point that says take the temperature in the cold aisle and the planar temperatures and combine it and give me a stochastic average, right? So you have this ability to really think about how you want to review and dig into the data center and how you want to manage it in a way to be very smart. And the point of the car analogy is I will haggle at the car dealership to save $500, but I have a $600 phone, right? We know how valuable that is to our life now. We don't haggle over software. We will haggle over the hardware because the hardware provides minimal value. All of the value comes from the software. And that's where we're at. The nexus we're at with data centers and where we're going from here on out is that all the meaningful innovation in data centers are going to occur in software and connecting that software to relevant and purposeful use. So with that, I'm going to wrap up. I've got 1 minute, 30 seconds left, apparently. So we got a few questions. Anyone? Oh, all right, we're wrapping up? Perfect. Well, thank you all. I really appreciate your time. I appreciate you coming out this morning. Always enjoy it.